Hi everyone and welcome to this new video of Data Science at Scale with VerticaPy. It's Badr speaking. Today we will strike a very interesting topic, data re-identification. Nowadays data storage have many limitations due to all the new restrictions. Indeed, you probably heard about the General Data Protection Regulation or GDPR. All the data cannot be stored, which can lead to biased computations. One of the challenges is to be able to work with totally anonymized data and to be able to match them together in order to use analytics. What are GDPR? How to do analytics on anonymized data? What types of functions do we need to solve these challenges? Let's try to answer to this question using a very interesting dataset, the EXPEDIA dataset. Let's consider the following scenario. A family decided to go together to vacation. They completed a form in the website and searched for a room with 2 adults and 1 child. They want to go from Paris to Boston in the middle of June. It is possible to match this information to some users we already know. Or can we match some collection of anonymous information together to create a consistent unknown user? This question is complicated. We need to understand what is data re-identification. Data re-identification is the practice of matching anonymous data with available information to discover the individual to which the data belong. We have to be very careful because we cannot use analytics on a specific individual for commercial purposes. We can do it on a group of persons. It is important to understand data regulation to avoid huge sanctions. The data must be protected and they must be used only when we get customers' agreement. When dealing with customers' time series data, we have to create interesting features. Sessionization is an important one to master. It allows to gather a set of successive actions together in order to do analytics at the top of them. As we will most of the time have irregular slice time, we need to find a way to interpolate and join many time series sources. When ingesting data, we have to follow the General Data Protection Regulation. We are collecting many information from many different users. It can be a location, a navigation, or pictures and videos. We need to inform the customer for this data collection, and he will have to accept it. Otherwise, we will ingest incomplete data. The data are then stored in a safe place and anonymized. The data can then only be used for commercial usage only. We can see clearly the complexity of the situation. Indeed, our database can contain multiple information, but some of them could be lost. Indeed, as long as the customer is not giving his agreement, we are limited in the data storage. Let's consider the following scenario. A customer decided to log into the system. At the first appearance, he did not accept data sharing. We are losing a part of his data. Later, he can decide to accept the operation. We can store the data, but he can refuse later, and then accept again. Finally, we are facing a very complex use case, where we will not be able to identify the source of our data. We can then have multiple gaps when doing analytics. How can we work correctly that way? We need to understand a very interesting functionality. Sessionization. Let's consider the following click sequence, which belongs to the same user. The first 3 clicks are happening between 11 AM and 11:30. This click sequence represents a session. Another visit happened later at 2 PM, and it ended at 2:30. As this visit took place more than 30 minutes after the last visit, we can define it as another session. Finally, during night at 8 PM, the user decided to do 4 visits and to book at the end of the session. This click sequence happened more than 30 minutes after the previous visit. It is then another session. We can compute many aggregations for each session, like the session duration, the session click frequency, if a session ended by booking, the most visited hotel. All these aggregations are very important to do re-identification or data matching. Indeed, we can do joins and interpolated joins. That's a very interesting feature which is available in Vertica. Let's consider the 4 following sessions. We don't know who is the last user. It's then easy to join the 3 first sessions information using the user ID. For the last one, we can interpolate by looking at the closest session having approximately the same elements. It is then possible to use similarity between different sessions to match some of them. As we are working on a group of users and not user-specific, we can then do session matching and follow GDPR at the same time. It is possible when having an efficient database with many functionalities like sessionization, pattern matching, and in-database machine learning. It can use flex table and query any data structure. The data can be on-premise, in the cloud, or even in HDFS. Any ETL tool can be used to pre-process the data. And any BI allowing ODBC, JDBC connections can be used. Integrations with many tools are available, like H2 or TensorFlow. In-database datasets with VerticaPy and many built-in functions. The possibility of creating our own user-defined functions in 4 programming languages, C++, Java, Python, or R. Vertica allows to centralize all the different data structure in one place and to do in-database analytics to solve complex use cases, like data reidentification. To illustrate it, it is important to do some hands-on. We will use VerticaPy and Jupyter to do data reidentification on the EXPEDIA dataset. We will ingest the dataset, do some features engineering, use time series interpolation to do data reidentification. Let's go! We will use the EXPEDIA dataset. It is available in GitHub and it is a quite complete one. We have access to many information like different user IDs, if the user is using a mobile or a computer, the hotel he's searching and other information like the hotel country, continent, etc. The check-in date, the checkout date, if the user is adding a flight, the number of rooms, the number of adults, the number of children, etc. All these information are represented by different variables that we will use in order to re-identify the user. Be careful, we are not finding the user himself but his ID. This one is anonymized as it is totally forbidden to track the user's activity without their agreement. The goal is to create a model which will match user session ID only. It must be used on groups of users and not individual to follow GDPR. If you are interested, another study on the same dataset is available in the VerticaPy website. It is more focused on booking predictions. Let's now jump into the study. Let's use Jupyter Notebook to illustrate this topic. Let's load the VerticaPy package and its SQL extension. In VerticaPy, it is possible to work both in Python and SQL. All the computations are pushed to Vertica. Be sure to have the same or an upper version to avoid compatibility issues. Let's create a new schema for the study. We will name it EXPEDIA. Let's load the EXPEDIA dataset in the Vertica database. We use the reidCSV function with the parameter parseEndLines to only parse few lines for the type identification. After guessing the different data types, it will ingest the entire dataset. The sessionize method will create the different user session. We will use a threshold of 30 minutes. We can then compute the different sessions aggregations, session duration, hotel cluster mode, if a user booked at the end of a session, etc. We can see the combination between Python and SQL in VerticaPy. We can get the advantages of both programming languages in one API. Let's save the different user session in a new table. And split the dataset into a train and a test. We will try to find the user sessions in the test dataset using the train dataset. In order to do it, we will look at the closest session having the same characteristics. We use Vertica time series joins to easily interpolate and join the two data sources. The interpolate previous value predicate replaces the equal symbol. Vertica makes complex operations very easy to achieve. With too many conditions, we will not be able to join all the datasets. In our case, we successfully joined 31% of the data. And we are matching 35% of those sessions to the correct users. It is huge as we have more than 40,600 users in the dataset. We can be more precise by adding more conditions. But it will reduce the number of joins matchings. In our case, they represent only 6% of the test set. Look, we increase the matching accuracy. We are reaching more than 68%. The strategy could be to use joins with many conditions and then to relax the entire query and find more and more matchings. With VerticaPy, we can compute advanced analytical features and solve very complex use cases with few lines of code. Sessionization, time series interpolation, moving windows can be computed using high-level functions. That's just magic. Thank you for watching this video. If you liked it, subscribe to the VerticaPy channel in LinkedIn. Visit our GitHub page and add a star to the project. Learn more by visiting our website at vertica.com/python. You can also subscribe to our YouTube channel. See you soon for another video.